Asperitas is a striking but rather unusual cloud formation that resembles rippling waves. It was formerly known as undulatus asperitas. When viewed from below, these wave-like formations that grow on the cloud's underside give the impression that it is a rough sea surface. Despite their ominous, stormy appearance, they almost always pass without producing a storm. The American Plains states have seen a lot of ominous-looking clouds, frequently in the morning or midday hours after severe thunderstorm activity. To know more about these rarest clouds, continue watching our channel, Theory of Science. Before these rarest clouds disappear, make sure to subscribe to our channel, hit the bell icon to receive notifications. Although the formation of Asperitas clouds is relatively mysterious, there is much discussion and misunderstanding around this topic. Although they have been spotted in relatively calm areas as well as during convective thunderstorms, it is hypothesized that their presence is related to the consequences of convective thunderstorms. According to one idea, they are created when mammatus clouds fall into regions of the sky where the direction of the wind shifts with height, creating a wave-like motions. The formation of wavy cloud base, like what that observed with Asperitas, requires unstable atmospheric circumstances, which is obvious. Asperitas have come to be associated with thunderstorms that follow, even though the formation itself does not create rain. Although convective rain clouds can grow under the same unstable atmospheric conditions that are needed to form the wavy cloud base, this means that Asperitas may be accompanied by other cloud that produces precipitation. In 2008, the Cloud Appreciation Society proposed that this previously unknown cloud structure be included in the World Meteorological Organization's International Cloud Atlas. Public submissions of photographs of the spectacular cloud formations between that time and 2015 helped to strengthen this argument. Asperitas became the first new cloud type since the cirrus torrentis in 1951, when the classification was approved at the WMO's 17th Congress in 2015. Asperitas' habitat type has yet to be identified, but the WMO started investigating the cloud's mysterious in 2008. Although Asperitas clouds have been spotted all over the world, including in Alabama and New Zealand, it is rather uncommon to encounter these striking clouds. However, the majority of sightings share one common thing: inclement weather. So make sure to look up if you ever find yourself somewhere where a clear view of sky shortly after a storm has passed, such as a thunderstorm hotspot like the Great Plains. James Montagu, who lives in the shores of Lake Ontario, has witnessed his fair share of unusual sights, but the cloud formations he saw seemed like they belonged on another planet. An undulating display of Asperitas clouds, also known as undulatus asperitas, was photographed by a photographer residing in Rochester, New York, against a stormy gray background. There's no doubt that clouds can sometimes look scary. During severe summer storms or spring tornado season, certain cloud formations can cause the sky to take on an eerie, ominous look that resembles more of an apocalypse or a scene out of Doomsday than a weather event. Asperitas clouds are no exception. Make sure you subscribe to our channel for more amazing content like this, before the next cloud scares you. Skywatchers and cloud spotters appreciate the uncommon and beautiful Asperitas clouds. They develop when the atmosphere's low or middle levels are stable and allow for horizontal layering of air. Those layers are disturbed by a nearby perturbation, which causes waves to riffle through them. The ensuing interference pattern can cause formerly flat layers of cloud to become wonky, wavy patterns when several perturbations coincide. The majority of these clouds are seen alongside stratocumulus and altocumulus. They were seen on camera by Janet Salzman on July 23, 2013, as they walked along the Nova Scotia's south shore. One of the most spectacular Asperitas cloud formations was recorded by Witta Priester in New Zealand in 2005. On October 28, 2013, an Asperitas cloud layer appeared over Tuscaloosa, Alabama in the United States. On July 7, 2014, Asperitas clouds occurred over Lincoln, Nebraska in the United States. Gavin Prater-Pinney responded to the introduction of the cloud by stating, "Asperitas was detected with the aid of citizen research facilitated by modern technology. We are able to see patterns when Cloud Appreciation Society members submit images of stunning skies from throughout the world, which is how our suggestion for a new categorization came about in their comprehensive reference guide to cloud classification." The Linnaean nomenclature used in the Worldwide Manual for Cloud Identification has been in use since the early 19th century. The WMO is in charge of updating the Cloud Atlas, but updates are incredibly rare. Cirrus Torrentis, which was first added in 1951, was the last brand new formation. Asperitas clouds have been seen to be stratocumulus or altocumulus. Still, They are currently regarded as mostly a supplementary feature of stratiform clouds, which are low-elevation layered clouds without vertical development. It is interesting to note that while stratiform clouds often have flat bottoms due to fluctuations in wind and temperature, the tops of these clouds frequently show prominent features. If you've ever gazed out a plane window, you'll undoubtedly be familiar with this since it happens frequently. Asperitas clouds are unusual because of the intricate formations at the bottom. An article aiming to outline the characteristics and factors that lead to the production of Asperitas clouds was released in 2017 by academics from the Cloud Appreciation Society, the University of Reading, and McGill University. The authors claim that the undulatus cloud type, which is possibly related, lacks the smooth, undulating shape, and that Asperitas clouds are distinguished by their rough, somewhat wave-like cloud base. Because of these semi-wave-like properties, the authors postulate that weak oscillatory activity is probably what causes Asperitas' clouds. There are several possible causes for this. Orography, or the wave-like movement brought on by the flow of air over high terrain, is one. There may be additional causes, such as atmospheric gravity waves, horizontal wind shear, or convection, which is the transfer of heat or matter between fluid entities. That's all for today. If you enjoyed our video, please like it and subscribe to our channel for more interesting content like this. Hit the bell icon to receive notifications, and also check out our channel for more interesting videos like this. See you next time.